recording. Let's take a look at some problems from Packet 1 on particle motion. Question 1. An object is being dropped from a height of 128 feet. When does it hit the ground? Round to the nearest thousandth of a second. S of t equals negative 16t squared. This comes from our work on the notes, plus 128. Solve for t. It will hit the ground when s of t is equal to 0. Find out then when this equals 0. Solve for t in your calculator. 2.828 seconds. What is the velocity of the object at impact? Round to the nearest 3 decimal places. V of t equals negative 32t. Plug in our value from above. And we get approximately 90.510 feet per second. Okay, question number 2. An object is thrown downward from the top of a 300-foot building with an initial velocity of 30 feet per second. What the position function for the situation described? So position equals negative 16t squared minus 30t plus 300. Part B, what is the velocity of the object after 1 second? V of t equals the derivative of position, which is negative 32t minus 30. Plug in 1 for t into the velocity function. Negative 32 times 1 minus 30 equals negative 62 feet per second. Question number 3. A coin is dropped from a height of 750 feet. Use s for height in feet and t for time in seconds. Answer the following. Find the average velocity on the interval. Average velocity. Okay, on this problem, average velocity, the keyword is average velocity. Average rate of change is going to be our f of b minus f of a. So we take s of 3 minus s of 1 divided by 3 minus 1. Notice that we're plugging it into the s function. We're basically getting the secant slope. Remember, derivative is always slope. So you're getting the secant slope kind of idea. So we have to plug in 3 into the s function. Our s function, I'll write it on the side over here, equals negative 16t squared plus 750. If we plug it in 3, we get 606. Plug in 1 into the function, 734 over 3 minus 1 is 2. So that will equal negative 64 feet per second. Part B, instantaneous velocity, that's our derivative. Negative 32t. Plug in 3 to get the velocity when t is equal to 3. Negative 32 times 3 equals negative 96 feet per second. Part C, how long does it take for the coin to hit the ground. 0 equals negative 16 t squared plus 750. Finding the position again when it is 0. Solve for t. Again, you can do this in your calculator if you wish to. T equals 6.847 seconds. Find the velocity when it hits the ground. We're going to plug in our value then. V of 6.847 seconds, negative 32 times our value. We get approximately negative 219.089 feet per second. Okay, question number 4. Which of the following depicts the correct motion for the particle moving along a straight line with the position function s of t equals t cubed minus 12t squared plus 45t plus 2? So what I would do for this one is figure out the v of t. V of t equals 3t squared minus 24t plus 45. Figure out some values for that and then look to see a of t. I guess I would also look at here 6t minus 24. I would plug in some values. You can see that they're looking at, looks like we're looking at values of 3, 4, and 5 if you look on all the graphs. So I would just plug in those numbers to see where it's positive and negative. Remember, where both of them are positive, you're speeding, or negative, both negative, you're speeding up. One positive, one negative, slowing down. Correct answer when you try and plug those in is answer E. Question number 5. Stone is thrown upward from the top of a building. Its height above the ground after t seconds is given by our function s of t. What maximum height does it reach? So we want to figure out, again, maximum height on here. So when we're solving it, think of maximum, minimum again as our values where the derivative is equal to 0 will give us a maximum or minimum. Take a derivative. So negative 32t plus 48. Where the slope is 0 is where there's a max or min. Negative 32t equals negative 48. So t is equal to 1.5. Plug 1.5 back into the original function to find its position. Negative 16 times 1.5 squared plus 48 times 1.5 plus 92. And we should get an answer of B, 128 feet. Number 6. The following is correct regarding the direction in which the particle is moving. Find the derivative. 3t squared, so v of t equals 3t squared minus 8t plus 5. I'll graph it to get my critical points. So if you graph that function where it's equal to 0, critical points are 0, or where the derivative is 0 or the slope is 0, so that's at 1 point. 0.333, which is 5/3. So if you graph that and look at it, or you can just plug in some numbers, you'll find our correct answer of D. Between 0 and 1, the particle is moving to the right, and between 1.333, which is 5/3, and 5, the particle is also moving to the right. So that would be the correct answer. Remember, where the velocity is positive, the particle is moving to the right. Where velocity is negative, the particle is moving to the left. Also remember that when you're looking at a derivative graph versus the function graph, and when you're looking to see what's happening, check to see what the slope is. So remember what you're graphing, derivative versus function. Number 7. Velocity is given, so this time it's the velocity. Find the velocity when t is equal to 3. So this one should be pretty simple. We're just plugging in 3 for t. 2 times 3 cubed minus 3 squared minus 4, which equals 41 meters per second. Find the average acceleration. So now we're getting acceleration, not average velocity. When you're doing average acceleration, you're getting the derivative of velocity. But instead of just finding the derivative using our rules, average means we're going to find the secant slope. So if we plug in 2 and 0, we get 8 minus negative 4 plus 4 over 2, which is 12 over 2, or 6 meters per second squared. It's acceleration. And part C, find the acceleration at time t equals 3. So this is where, when it just says acceleration, we'll take the derivative, 6t squared minus 2t. We're going to find where that is. Find the acceleration when t is equal to 3. Plug in 3. 6 times 3 squared minus 2 times 3, which equals 48 meters per second squared. Okay, last part of that problem. Find the speed of the object each time the acceleration is equal to 4. Acceleration is 6t squared minus 2t. Find where that equals 4. I'm going to bring the 4 to the other side. Factor out a 2. And solve for t. We get t equals 1, or negative 2/3. We're going to then take that and put that into the original function for the velocity. So if we do that, we're going to have v of negative 2/3. We're finding the speed, so don't forget absolute value around that. And then absolute value v of 1. So we end up with 5.307 meters per second, and v of 1, absolute value is 3 meters per second. Alright, moving on to question number 8. Particle moves along the x-axis, position is given. For what value of t is the velocity of the particle equal to 0? Find the velocity function first. V of t equals 2t minus 7. Find where that equals 0. So t is equal to 7/2 or 3.5. Which is answer choice C. Number 9. A graph of velocity is given. So you have the graph on your paper. During what time interval is the acceleration of the bike positive? You also have a graph to look at. So you have both of them on your chart. I don't have them on here, but you certainly can look at yours as we go through the problem. During what intervals is the acceleration of the bike positive? So where the velocity is increasing is where the acceleration is positive. So we're looking for where the velocity is increasing. And if we take a look, that would be from 0 to 45 and from 55 to 60. Part B, find the average acceleration of the bike in feet per second over the interval between 0 and 60. Average acceleration we're finding again. So we're going to take 47 minus 0 over 60 minus 0. It's 47 over 60 feet per second squared. How do we get those numbers? It's just V of 60 minus V of 0 over 60 minus 0. All right, last part of this question says find one approximation for the acceleration of the bike in feet per second squared at time 30. Show the computations that lead to your answer. For acceleration, since we are not working with a function, we have to use the average acceleration, V of 35 minus V of 25 divided by 35 minus 25. Look them up on the information that you're given. So 42 minus 35 over 10 equals 7 over 10 feet per second squared. All right, for the rest of the packet, there will be some solutions that you can take a look at. But go ahead and try the rest of them, and it's kind of the same kinds of questions asked in a lot of them. Make sure you're checking to see, are you finding velocity or acceleration? Are you finding a time? Are you using a time and plugging it in? So read through the rest of the problems and solve them.